Okay, so at long last, we finally can get started, right, on these. Remember, we took a while to now understand almost every of these symbols. We have the language in place. Remember, there's two questions we started off with in the last lecture we talked about. To study a subject, we first need to learn the definitions of the language. So now we know the definition of every single term we're going to use. And then we want to know how these quantities relate to each other. And now we answer the second question, how they relate to each other, and brings us to the four famous kinematics equations, right? Those are the four equations you will need to memorize, you will need to know. You can, it's going to be provided in a textbook or in an equation sheet, but to be able to really use them effectively, have them memorized, it's pretty simple. I'll show you how to do that. Right. So start off, right? These are the standard kinematics variables, sometimes called the SUVAT variables, right? All right. So sometimes I abbreviate with that, but it basically refers to all of them. So this is displacement, right? U is standard for initial velocity. V is final velocity. A is acceleration. And T stands for time. Notice I don't have initial velocity, sorry, initial acceleration and final acceleration. Why is that? I don't have initial displacement and final displacement. Why is that? All right, let me write down the units as well, just while you think about that. So the units, meters, these are the standard units, standard SI units. So whenever all the examples, I'm not gonna, if I don't write a unit, I'm using SI units. So meters, kilograms, and seconds, everything is in. So velocity is in meters per second, acceleration is going to be meters per second square, and time is going to be in seconds, right? Those are the units. Now, acceleration, the reason is we're going to deal with what type of acceleration problems? We're dealing with constant acceleration, right? So if it's constant, there's no initial and final, it's going to be staying the same number. But velocity has changed, right? If you have acceleration, the final will either be faster or slower than the initial, it will change. How about initial displacement and final displacement? Well, there's no such thing, right? Displacement is final position minus initial position, right? Remember, displacement is delta x. It's x final minus xi, right? If we're in one dimension. So displacement already encapsulates final and initial. There's no such thing as initial. Displacement is already between 2 points. So there's already an initial and final, all right? So with that clarification in mind, all right, so the next question is how do these things relate to each other? If I know the initial velocity, what do I need? What additional information do I need to find the final one, etc. So we have 5 key players over here. You might expect if I have if I want to find out one of them, let's say I want to find out the final velocity, right? Then you might expect I need 4 other things to find it, but turns out no. Turns out you only need 3 other things. You only need 3 out of the 5 to be able to find the other 2, right? It's pretty cool. So I'll show you. Go ahead and write them down first, and I want you to write them down as well, not only once but many times, because these are stats. It's so important that you want to really commit them to memory in order to do all these problems effectively, right? One of my professor used to joke that your birthday, he used to say your birthday and your social security number is something you look up, but kinematics equations is something you know. All right, so it's that important. Okay, so let me write it down first, and you can copy them. So let's see if I remember them as well. All right, so the first one is V equals U plus AT. Okay, the second one is S equals U plus V divided by 2 times T. S equals to UT plus 1/2 AT squared. And the last one is V squared equals to U squared plus 2AS. Okay, so I'm going to put them in a box, right? So these are the 4 equations. Okay, so normally when we get a bunch of equations or even one equation, nonetheless, there's two questions you immediately want to ask. This is a general studying skill. You want to ask 2 questions. You want to ask, where do they come from? Right? Are they, God-given by God? Like, is it some truth that just popped out of nowhere and we need to just memorize it? Or is there a reason behind this madness? All right, there is a reason behind this madness. We'll get to it, and it's something you can figure out yourself, right? We'll get to that. And the second question is, once you know where they come from, is how do you use them? How do I use them? Okay. Now, of course, in most of your homework and exams, you're going to be tested on how do you use them. But if you don't know where they come from, first of all, it will make your life very miserable in using them because you have no idea what that means. And more importantly is, if I tweak the question a little bit, you'll immediately fall apart and you will not know how to solve the problem because you don't know where they come from and you don't know how to tweak them, right? So normally, when we study physics, normally the procedure is start with this and then this, right? Understand this concept, that's usually the main job of the lecturers, to give you the big picture, understand the concept, and then you can read the book and use the discussion sessions and use the homework to figure out how you use them, right? So usually that's the way to go. However, I'm going to swap this around. I'm going to do something unheard of. I'm going to show you the practical application first and not tell you where they come from, right? This is one of the exceptions that I'm going to do this and then come back to it, okay? Because it's so easy to use them if you know how to use them. Even if you don't know where they come from, it's so really easy to use, and I want to show you that first, right? So yeah, we'll do that, and so I'll go about and talk about how do we use them. Okay, so a couple of ways. The first thing to use them, in order to use them, the first thing you want to do is memorize them. Okay, and I'll give you a couple of tips. Usually, I'm not a big fan of route memorizing most of the time, but this is so worth it, right? But I'll give you a couple of tips first. First of all, notice each one of them. How many out of the 5? We have 5 key players. How many variables do we have in each one? Over here, I have 1, 2, 3, 4. I have 1, 2, 3, 4. I have 1, 2, 3, 4. T is the same thing. And 1, 2, 3, 4. Notice each one only contains 4 out of the 5 variables, right? Even though T appeared twice, it's just one of the variables. So in fact, you will notice this one has no S. This one has an absence of, which variable is absent? You can fill in the blank. Which variable is absent over here? Can you find out what variable is absent over here? All right, so each one actually misses a variable out of them. So the answer is this one has no A, this one has no V, this one has no T, right? So this is what you will realize. So if you memorize it and then one day when you write it out and then you suddenly realize, hey, I have 5 out of all 5, that's something wrong. There should be only 4 and each one misses one of them, all right? And this is really the essence of why we only need 3 out of the 5 in order to solve for everything. For example, if I have V, U, and A, I can solve for T out of this. I don't need an S. So S is not even needed in order to find it. Or if I have U, A, and V, so U, A, and V, I can find S, right? U, A, and V, I can find T, right? And I can use this to find S, I can use this to find T. I don't need 4 out of 5 to find the rest, I just need 3, okay? So that's the minimum information you need. So we'll see later on, right? If I drop something, you just need to know 3 out of the 5 things, and then you can know everything else about it, right? Those are the quantities, those are measurable things about motion, okay? So this is tip number 1. You have a missing variable in each. Tip number 2 is the left-hand side only consists of V and S. Okay, so that's another easy start. I usually remember in this order. So sometimes when I refer to the first one, the second one, the third one, the fourth one, I usually follow this order. It's just my way. Different books may present them slightly differently, but I think this is the easiest. It's up to you which one. But just in case, when I say the third one, I usually mean this one like that. Okay. Yeah, so there's a V square. Now, note, so this is the second tip. The left-hand side, LHS, left-hand side, it only consists of V and S, all right? So if you notice you have a U on the left, you'll probably, it doesn't mean it's wrong. You could have this term over here and this term over here, but you're that's just not the way that's easiest that I find. The second tip number 3 is they're all plus, okay? So there's always, so they're all pluses, okay? In here. So if it's very easy, so you don't need to worry about negatives, right? Negatives, you have to remember which one subtract which one, but it's all plus, okay? And the last tip is there's no squares except for the last one. So only, oh, sorry, there's a square here. Yeah. So most of them doesn't have square, but the last one is sort of famous for a reason. So let's not say this, but let's not make this a formal tip, but it's just the way I remember it. These two doesn't have a square, and that, yeah, you can write that out. Tip number 3, tip number 4. So roughly remember where does the squared variables go, roughly, right? And say that a couple of times. So v equals u plus at, s equals u plus v divided by 2 over t, s equals to ut plus half at squared. This is actually a very famous one. These two are used a lot, actually. V squared equals to u squared plus 2as. All right, so it spells out like s. I don't know if that helps or not, but yeah. So a lot of u's, a lot of a's on the right, and so these are the tips. Okay, so in the next video, I'm gonna immediately show you how do we use this, right? So at first, at the moment, I want you to suspend your disbelief and just assuming these are magical equations that just solves everything. And then at the end of the lecture, we'll see why they are true. They're not just popped out of nowhere, but they're extremely easy to use and wait. And I just want to show you how easy they are first.